So, good evening, or good morning, good afternoon. There's people from all over the world tonight. I will keep my introduction very short because we have only 20 minutes with Robert. It's my pleasure to introduce Robert Mueller today. Robert is the senior technologist and principal investigator at the Exploration System and Development Office at NASA, more precisely at the Kennedy Space Center. Robert, thank you for joining us tonight, this morning for you.
Good to be here. Thanks for inviting me.
Very good. Again, like I was saying, we have very short time. I have my timer beside me. I want to give you all the time, so I will ask you the first question right away. Robert, I was reading again lately that there was some news about substantial amount of water found on the moon, and there may be a race for that coming on, which will come to mining later on. And so I was wondering because I always been reading about helium-3, and now we're talking about water. So this race to the moon, to the resource of the moon, would it be about water or helium-3?
Well, first of all, let's address this idea of space mining. Exactly what is it? Many people think that it's mining an asteroid, bringing materials, minerals, metals, resources back to Earth and using them on Earth. We don't think that's the case. We think that the resources in space will be enabling for space missions in space.
Yeah.
Bringing resources back to Earth is a very small category. So in your question, yes, it's absolutely true. The change in the last 10, 15 years has been that we have orbital data from missions to the moon that indicate the presence of hydrogen at the South Pole and North Pole of the moon, which indicates water. One mission we had was an impactor. We impacted a rocket stage into the South Pole of the moon in Cabeus crater, and we discovered 5.5% water in the ejecta plume with the use of mass spectrometers on orbit. Well, that was a very good indication for us that there's 5.5% yield water when you dig up the regolith, the crushed rock on the surface of the moon. That was a very promising sign. Now that indicates that we have water for use on the moon and in the lunar vicinity. Water is very important because it's hydrogen and oxygen, which is the most efficient rocket propellant we have today, the most efficient chemical rocket propellant. It has a specific impulse of 450 seconds. The space shuttle used hydrogen and oxygen is extremely efficient. So if you're talking about transportation or even life support, you can drink the water. You can use the water for radiation shielding. You can use it for coming home. You can make the propellant on the moon and come home with it. So for use on the moon, the water is absolutely essential for sustainability.
Okay.
And we want to become Earth independent. Now, helium-3 is a different story. Helium-3 is an ore body on the moon. It's an isotope of helium that comes from the sun. And the sun streams these particles out over 4.5 billion years and has embedded these particles in the surface layers of the regolith. The helium-3 does not exist on Earth because the Earth's atmosphere protects us from the sun, and we have a magnetosphere, and these helium-3 isotopes cannot penetrate the Earth's atmosphere. So we don't have helium-3 on Earth. We have some as a byproduct of nuclear reactions, but very little. Helium-3 is an enabler for nuclear fusion as opposed to fission. If we can manage to harness fusion, all our energy needs on the Earth will be met with clean energy. So the idea is that we go mine helium-3 on the moon, bring it back to Earth at a value of about $3 billion a ton, and that is a profitable business case. Most business cases for bringing resources back to Earth are not profitable. They're not viable, but helium-3 might be viable. So that's the difference. Water will be used in space, but helium-3 could be exported from the moon and imported to Earth.
Okay, so the answer to my question then is water first, helium-3 maybe after.
Correct, because we need the infrastructure on the moon in order to mine the helium-3. So it's a step-by-step process.
Now, back to the mining itself, there's a debate right now between what is the most efficient. Are we talking about human mining or robotic mining? We know the condition out there is very, very harsh, to put it very mildly. Where are we on this debate? Are we looking at the human presence or robotic presence when it comes to mining, in your point of view?
It's a big trade-off. As you know, the Mars missions have used robots for the last 20 years very successfully.
Right.
And in fact, it's been an amazing program. The Mars Exploration Rovers, the Mars Science Lab. We're getting ready to launch the next rover that will go to Mars at the end of July. And so we are making excellent progress on Mars with scientific studies using robots. But that entire period of the last 10 years with a robot exploring Mars could have been done by a human in 2 weeks. So robots are cheap, relatively cheap compared to human missions, but they're extremely slow. There's also a time delay between sending a signal from Earth to Mars and back of 40 minutes. So with this time delay, you cannot operate the robot with a human in the loop. It has to be autonomous. So the autonomy technologies need to get better. So in answer to your question, yes, robots work, but they're very slow and very inefficient. And humans are very flexible and very fast. So there's a middle ground. There's a middle ground where we use the robots for the hazardous environment. If an astronaut goes on a spacewalk 2 times in a week on the moon, that astronaut has met their radiation dosage limit for the week. They can't go out again. So the robots will have to be the helpers. They'll do the work, and then the humans will go out to do the troubleshooting, the maintenance, spare parts, swapping out parts. So for me, it's a perfect team. The humans provide the ingenuity, the flexibility, the curiosity, the scientific integrity, and then the robots are the workers.
Very good. Make things clear. So the answer is a little bit of both, finally.
Yeah, I think so. I think we call it actually cobotics, cooperative robotics.
Very good. So that's something I need to remember. Thank you, Robert. Now, correct me if I'm wrong. You were talking about the business case just before of Helium-3. What will be the economic threshold of mining space, of mining the moon? Am I looking at the wrong way when I'm thinking, by example, of the usual economic equation? We're talking about money, and we're talking about gold or US dollar, let's say. What will be this whole economic equation or structure if it goes that far? You know, because between you and I, we all both know there's ample of resource left on Earth, right? So before it's worth it to go that far. But again, I'll let you answer my question. I'm sorry, I will go on and on.
So the question needs to be asked: what adds value in space? What is it that we need?
Exactly.
That dictates the value. If you give me gold on the moon, if you give me the choice of having a kilogram of gold or a kilogram of water, I think the water will be much more valuable than the gold because it will keep me alive. In also, the water is my fuel. It's my propellant, fuel and oxidizer. And so now I can travel back home to Earth and to other places in the solar system if I have water. So the value proposition in space is really all about the water. The water keeps you alive. The water gives you transportation. So the water has the economic value. But beyond keeping you alive, what the water does is it's a form of storing energy. If you take the water, and we have plenty of energy on the moon from the sun. There's no atmosphere, the atmosphere doesn't attenuate the solar rays like it does here on Earth. So on the moon, you have plenty of sunlight. You can take the water, you can electrolyze it and store it as hydrogen and oxygen. So it's a way of storing solar energy very cheaply. So now, in answer to your question, the economic value, you can measure it in terms of energy. Everything in space is the currency of space is energy. If you want to survive, you need energy. If you want to go from point A to point B, we call that a delta velocity, delta V, you need energy. So if you can store the sunlight's energy in the water by electrolyzing it and turning it into hydrogen oxygen, then using that in a fuel cell or a rocket engine, that opens up the whole solar system. So that's the currency of space, is energy, and the way of storing that energy is in the water, and so the currency of space is water.
Well, that's an amazing concept. I mean, so I was wrong with my my good old economic equation. Thank you again, Robert. Now let me put my lawyer hat, which I try not to do too often, but without getting too technical, we have this outer space treaty, which is a lot of debate about this treaty, and I'm far from being convinced that mining is under. I mean, mining is somehow regulated by this treaty, but let's say that it is. The treaty does specify very clearly that nobody can claim any territory outer space, especially in the moon. So how can someone, how can a government, how can a corporation even can secure let's say an exploitation on the moon, or and therefore be able to invest what is needed and to keep it working in a way? What would you be your take on this?
The 1967 Outer Space Treaty tries to address that.
Mm-hmm.
And these lawyers were very clever. They left it open. They left it open. They left enough room for us to negotiate these issues. It's not completely excluded, but it's not completely included either.
Right.
So there are different camps on how we should treat space. Some people think it's hands off, don't touch it, the province of mankind. And some people think we should go use it to further the human species. So there's another treaty called the Moon Treaty from 1979 that tells you, it absolutely tells you, you cannot use resources in space. Some countries signed up to that. The United States never ratified that, and many other Western countries never ratified that because it precludes economic activity in the solar system. Mm-hmm. So that is not really up for debate because it's not ratified. The Outer Space Treaty is up for debate because it was signed by most countries, most developed countries. But it was also written in the time of the Cold War and the early days of the exploration of the moon. So it has a bias towards those days. And in those days, we weren't thinking about using space resources as much as we are now. Lately, the United States has issued the Artemis Accords. And the Artemis Accords are a set of guidelines. It's suggested guidelines for consideration by the global community. Sometimes we call that soft law. If enough people sign up to the soft law and use the soft law, over time it becomes hard law. This is just a legal thing, which is not my area, but I'm learning about it by necessity. And in the Artemis Accords, we have one statement in the Artemis Accords that says, when you go to the moon, in fact, the United States has already allowed the use of resources on the moon. The Outer Space Treaty only precludes claiming territory, sovereignty on the moon. You cannot claim any land on the moon. But utilization of the resources without claiming the territory is acceptable under United States law. Under the Artemis Accords, in order to establish the mining rights, what we've done is we put in a safety exclusion zone. When you come into the mine site, we put up a perimeter of about 2 kilometers, which protects you from the blast ejecta. When you launch and land a rocket, it ejects material up to 2 kilometers and maybe a little further. Some of it goes into orbit. And this could damage anybody in the vicinity, any equipment, any people. The particles travel at 2,000 meters per second. And just for reference, a speeding bullet travels at 500 meters per second. So it's 4 times faster than a speeding bullet. So we've established these safety perimeters. And I think that's a good way of operating. You set up your mine, you establish your safety perimeter, you don't claim the land, but you are allowed to use the resources, but other entities or nations cannot enter your safety perimeter for safety reasons.
So all for safety. This is definitely an elegant way to put it. I'm sure that there was few lawyers involved in that too. With all due respect. Robert, we still have a few minutes left. Where are we in 20 years from now? I know this is a loaded question, but from your point of view, from everything you've seen in your career, where are we in 20 years from now?
So in my career, the future has always been 20 years away. And no matter when you say we're going to be there, it's always 20 years away. And that is because we've been following a government model of taxpayer-funded exploration. But this is changing. Now we have the private sector involved. And in fact, it's the Apollo generation. It's people that were born in the 60s and maybe 70s, and they experienced the Apollo spirit. And they understand this huge human desire to explore the solar system. What's different is these individuals, like Jeff Bezos and Elon Musk, they have the capital to do it without government. And they are now embarking on this dream, which we were all sold as children.
Correct.
It never happened. So now the private industry is making it happen with government help, of course. So NASA provides the expertise, but the entrepreneurship, the innovation, the high energy, the speed, that's provided by private industry. So I think in 20 years' time, you'll see a very different model of space. Right now, we're in the time of the 1920s in the aviation industry.
Okay.
After World War I, a lot of pilots came back. They were unemployed, nothing to do. Aviation just languished, nothing happened. The government stepped in and issued airmail contracts. And then all these unemployed pilots from World War I became airmail pilots. Charles Lindbergh was one of those airmail pilots. That kickstarted an industry where the Boeings and the Northrop Grummans, all these big names, it's the same today. We have the Musks and the Bezos. And it was these entrepreneurs that gave rise to the aviation industry with government help through government contracts to kickstart it all. We're doing the same thing today. We're giving government contracts to private industry to deliver cargo to the International Space Station. This will kickstart the industry, and it already has. SpaceX is now reutilizing rockets, landing them on barges and on landing pads, cutting the cost dramatically. This is what's needed, is kickstarting, bootstrapping the solar system economy, and that's happening right now. So in 20 years, I'm very optimistic that private industry will be leading the way and government will provide infrastructure and stability.
But to all our friends in the mining industry that listening tonight, they have to start to get ready then.
Mining is a big part of this because without the resources, space will not be sustainable. We will not be able to have an economic equation that works. And the value proposition is really this. You have to mine the resources and use the resources at a cost less than bringing them from Earth. When we reach that tipping point of having local resources with Earth independence, that's the tipping point. At that point, everything starts going. And that's why we need the mining industry. The mining industry knows how to get the resources. We need help from the mining industry to reach that tipping point. When we can produce it locally for cheaper than bringing it from Earth, that's when the solar system economy will start.
Very good. Great way to end this tonight and this morning for you, Robert. Thank you again so much for your time. I'm sure we'll be talking again soon. Thank you, Robert.
Thank you for inviting me, and thanks for this great conference.
Great. Thank you.